Hi everyone, and thank you for joining this Cloud Native is Edge Native 2 short discussion. I'm Thomas Giacomo from SUSE, and the one thing I both cannot ignore and cannot talk about today is SUSE and Rancher, the chameleon and the cow, or the so-called cowmeleon. Now that it's out of the way, let me share how we see cloud native technologies, and many of them coming from the CNCF community efforts or based on them, how they are applicable to edge use cases. Edge computing has a lot of applications, and across many different industries, its adoption keeps growing. Similarly to cloud computing, edge computing requires infrastructure, application, and data management, and above all, a smooth and tight integration with on-prem private data centers and public clouds. And while the as-a-service approach of clouds and the device-based perspective of edge may initially seem very different, they are actually not disconnected. To be successful, they are codependent on one another. So let's take a concrete example with smart, almost smart enough to be self-driving cars. And bear with me, the picture of the forest shall make sense very soon as an edge and cloud visualization. So even though there's a lot of compute units and sensors inside a car, cars can be seen as the endpoint of such edge architecture. Cars in that forest are the leaves, and they happen to be green because they are smart, so they are clean as well. And smart cars do not only collect sunshine, they are generating tons of data. Some of it is processed locally, close to the compute, as for instance, latency is not a very good friend of driving reaction time. Some of the data is going back to the branches of the trees, going back to the on-prem or co-located data centers of the automotive manufacturers, where it is stored, analyzed, processed, and filtered. This is a two-way street, where the leaves get updates and instructions from the branches too. And actually, that's a multiple-way street, with exchanges coming from and to the trunks as well. And trunks here are public clouds, hosting centralized data and user applications, connecting with and to the car. Last but not least, and I would have even argue that it's the most important part of the entire forest, is the ground, the underground. That's where the seeds are fertilizing and supporting the health of this entire ecosystem. And that's basically you, users and companies, IT and developer professionals and teams, tools and processes to manage applications, infrastructure, security, observability, and so on. This is the layer that makes the entire forest a possible reality. So cloud-native technologies are very relevant for edge use cases, either directly or with some adaptations. And in any case, they help connect the dots with compute, for instance, as Linux and containers can virtually run anywhere. To illustrate that, let me share just a few examples, and there's many more, of some of the projects and where they could sit in that forest, as each layer has a different purpose and different requirements. Our leaves, the edges, can be anything from sensors, gateways, to small data centers. Usually, there's a lot more leaves than branches and trunks, and they are also much smaller, hence the need for optimized lightweight solutions. So technologies like KubeEdge or K3s enable edge-friendly Kubernetes environments, or Longhorn edge-friendly storage, persistent storage backend. The specific needs at that level apply to anything, networking and connectivity, as well as the operating systems with special flavors of Linux for edge. Technologies running on specific hardware and chipsets are often needed at that level as well, and ARM is an example of that. Going to the branches, our on-prem data centers, that's where you have a little more resources, more traditional compute and infrastructure setups. This is also where Rook with Ceph will be a very relevant storage backend, and it is where full-fledged Kubernetes distributions and clusters can sit too. And then to the trunks. We have the services public clouds offer there, say AKS, EKS, GKE, and others. All of that has to come together. If anyone becomes unhealthy, not implemented well, not talking to the others properly, the entire forest is at risk. On the ground, we need to abstract this whole ecosystem as much as possible, yet we need to manage all the components and all the layers of that forest, which are living and evolving things. And of course, edge computing networks get very fast, very large, very fast. And they include very different types of clouds and devices. Thankfully, there are projects that give us the means to cope with all the layers via multi-cloud, multi-cluster, and edge management capabilities. So in closing, I'd like to remind you that first, across industries and use cases, edge computing does require an integrated infrastructure that spans from edge to core to cloud. Second, cloud-native technologies are now being adapted and used for edge computing itself. And more importantly, these advances will enable Kubernetes and cloud-native technologies to become the unifying platform that make edge computing available to the world. I hope you take advantage of your time here at KubeCon to learn more about those projects and others, and that you remember that cloud native is really edge native too. Thank you.